All right, mathematicians, let's get started with section 4.5 on dilations. Our essential question, what does it mean to dilate a figure? Our objectives, mathematicians will be able to identify and perform dilations, solve problems involving scale factors and dilations. All right, let's get familiar with our first key point, identifying and performing dilations. Well, a dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point. We'll call it C. And the center of dilation is this fixed point. And our scale factor, which we'll identify as the K value, is the ratio of the lengths of the corresponding sides of the image and the pre-image. All right, so here's an example of a dilation that's a reduction, or in other words, a contraction. So this is our pre-image, which is the larger image, and it becomes the smaller one, so that means it reduced. Well, to get this reduction, the K value has to be some value between 0 and 1. To get an enlargement or an expansion, we would need a K value greater than 1. All right, a dilation with center of dilation C and a scale factor K maps every point P in a figure to a point P prime so that the following are true. And we can see by our illustration that if P is the center point C, then point P equals point P prime. We also can say is if point P is not the center point C, then the image point P prime lies on ray CP. Scale factor K is a positive number such that K is equal to the ratio of the length from C to P prime, so that's this length here, this full length, divided by the length from C to P. Angle measures are preserved, in other words, they do not change. And lines PR and lines P prime R prime are parallel. Lines PQ, so line PQ and line P prime Q prime are parallel, and line QR and Q prime R prime are parallel. So example 1, identifying dilations. Find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. So let's take a look at example A, where we see the safety pin clearly is an enlargement. So what we want to figure out is the scale factor. And the scale factor is a ratio. So when we're comparing the ratio of the side lengths, we want the distance from C to P prime divided by the distance from C to P. So that'll be 12 divided by 8, reduced to 3/2. So the scale factor is 3/2. That's greater than 1, so this is an enlargement. Take a look at example B. It definitely looks like it's smaller, so here's our pre-image without the prime symbol and then the prime symbol. So we're going to divide the distance from C to P prime divided by C to P. So that's 18 divided by 30, which reduces to 3/5, which is between 0 and 1. Therefore, it is a reduction. All right, key point number 2. There are some coordinate rules for dilations. So if the center is at 0, 0, then we can figure out the image by multiplying the K factor times all the X and Y coordinates. Sorry, implied statement, the pre-image, X, Y, and center 0, 0, scale factor equal to K, implies an image P prime at K times X, comma K times Y. If the center is not at 0, 0, and it's somewhere else in the coordinate plane, we'll call it A and B location. So we can use this formula to figure out the image P prime K times X minus A, outside that parentheses plus A, and then comma, k times y minus b, and then outside parentheses plus b. So our implied statement is the pre-image of p x, y, center at a, b, scale factor of k implies an image at p prime k times x minus a plus a, k times y minus b plus b. So it's a pretty lengthy formula, but it starts to make sense when we start using it. So let's take a look at example 2. You will need your own graph paper for this example. So go ahead and graph triangle ABC with vertices at the following locations and its image after a dilation centered at 0, 0 with a scale factor of 2. All right, so if we're considering the center at 0, 0, then that means we can multiply all of the x's and y's by 2. So we're going to map x, y coordinates onto double the x, double the y. So we would have a prime at 4, 2, b prime at 8, 2, and c prime at 8, negative 2. So your graph should look something like this. So ABC is enlarged to a prime, b prime, c prime by a factor of 2. Next, let's look at example 3, dilating a figure in the coordinate plane. So we're going to graph KLMN with vertices at the following locations and its image after a dilation centered at 1, 2 with a scale factor of 1/3. So let's take a look at considering our formula. So we would do 1/3 times x minus 1. The 1 comes from the a value of the center point, which is also the x coordinate. So whatever the x's are for the 4 vertices, so all these x's, we would plug in for this x coordinate right here. Subtract 1, and the 1 came from the x coordinate of the center point. And then on outside parentheses is plus 1, so we need to follow order of operations here. And then we'll do the same thing with the y, but we'll do minus 2, which is the y coordinate of the center point. So all the y coordinates of the vertices will plug into this y variable, then minus 2, and then order of operations multiply by 1/3, then add 2. So let's see the results. We would get k prime at 0, 4, should get L prime at 1, 4, should get M prime at 2, 3, and should get N prime at 0, 1. So let's take a look at the graph. All right, so the larger value is the original, the pre-image. So our figure, the blue figure KLMN is the original, and then K prime, L prime, M prime, N prime is the image. Now we have these dashed lines in here because I want to also explain there's an alternative way than this formula. So especially if this is not available on the formula chart, could get kind of confusing. So another way that we could dilate is also using slope. So identifying the point of the center point of dilation, so in this case 1, 2, we can plot a point here and then draw a line connecting to each vertex and figure out the slope of each line. So let's start with segment N to C. So that slope is up 3 over 3. So if I take 1/3 of that slope, that's going to be 1 over 1. So then if I go down 1, left 1, and plot, then I've got the N prime of N. I can do the same thing for K. So from C to K, it has a slope of up 1, 2, 3, 4, 5, 6 over 1, 2, 3. So 1/3 of that would just be up 2 over 1. And then I could plot K prime. Do the same thing for L prime from L. So it goes up 1, 2, 3, 4, 5, 6. So 1/3 of 6 is going to be 2. So divide by 3, and then that's another way you can dilate. All right, example 4, using a negative scale factor. So graph triangle FGH with the following vertices and its image after dilation centered at 0, 0 with a scale factor of -1/2. So when we're centered at 0, 0, it's definitely a lot easier to figure out the coordinates. You just multiply the scale factor by all the x's and y's. So when that happens, I get f prime at 2, 1, g prime at 1, -2, h prime at 1, 1. So let's see what that looks like as a graph. So here we have a dilation by a negative factor, and it kind of looks different as well. So it looks like it's kind of oriented in a different direction. So h prime is here, g prime is here, f to f prime here. And the center was at 0, 0 for the center of dilation. And that's all for our final transformation of the unit, dilations. So bring any clarifying questions into class and we will practice together.